this FIQ,
Put it in the basket.
since I wasn't here on Thursday. I didn't realize that you wanted the Delta Math test with all the work shown, so I did that yesterday. But I think it's going to be pretty easy for you to believe that I didn't cheat because I got 2 out of 10.
Okay,
So,
that's fine.
yeah.
I'll open up the corrections next Tuesday.
Oh, corrections, awesome. Thank
Yep.
you.
Mr. Townsend. So I wasn't here on Tuesday because I had an AP biofield trip, and so there's a lot of work that I was going to turn in to you that
Okay.
day in person. Is it still too late to turn that in person to you?
No, you can still turn it in person.
Okay, perfect.
It's like multiple pages. Yeah.
Thank you.
And then I have a 0 for 128, but I turned that into you Friday morning in person.
Did I give it back to you?
No, I don't have it.
Okay, you might check, you know where you turn in your phones for tests?
Mhm.
That white box underneath there?
Okay.
One of those drawers is for 4th period, so since it's recent, it should be on the top.
Okay.
So I either passed it back to you or put it in there, so I just need to see it again.
Okay.
I left my Chromebook in someone else's class. Can I go get it?
Yes, quickly, please. Oh, it must just not have saved. I'll get it fixed and give it back to you.
Thank you.
Oliver. Thompson. see here.
Good morning, everyone. Today is Thursday, April 25th, 2024. Would you please join me in a minute of silence? Please stand if you're able and join me in the pledge. I pledge allegiance to the flag of the United States of America and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all. Thank you. Have a great day.
Good morning, guys. I've got a ton of information I need to share with you guys here at the start of class, just a bunch of little stuff. But first up, if you forgot to turn in the homework, it was 129 circuit, so that was from 2 classes ago, but I think I gave you a little bit of time last class to finish it up if you didn't finish the class before. So if you forgot to turn that in Google Classroom, you can still get full points, but I need your hard copy in the basket before we get going this morning. Reminder about Delta Math test. Again, this last unit test is going to be a 30-point test, and we let you do it as a take-home test, but then the trade-off is the reason we let you do it as a take-home test is that buys us more time to do AP review. So I feel like that's kind of a win-win, except that you do have to take the time out to do that. I believe the deadline, but you need to double-check, should say in Google Classroom and in Delta Math. But for the first round, I believe the deadline is before class on Tuesday. So again, don't quote me on that, but that's what I believe it to be. So I'd asked you to do it for homework last time. If you didn't do it then, you still got time to do it, but now you've got other stuff stacking up. Also a reminder about that, make sure that you are writing your work down. You will have to turn in your work, and I will have to be able to see how you came up to that answer for me to count that as a point. Also a reminder though that we will open up corrections to it. So the corrections for Delta Math, I don't know if it's the same as how y'all used Delta Math in the past, but basically it gives you 3 more question types of the type that you missed. So if you missed question 1 on the test, you lose those points, but when I open that up next week, if you can then do that question type 3 times correctly 3 times, then you earn those points back. So you could potentially make a 0 on this part and still end up with 100 in the grade book, but it's going to be less work the better you do on the first 10. So make sure you're putting in your best effort. Again, that's calculator allowed. Use your notes. Take all the time you need to. You know, at this point, it's really in your interest to know that stuff anyway. Okay, also under upcoming assessments, so again, I asked you to do that last time, so that's why I didn't give you a mini quiz to study for last time. And the last 4 classes before that, I'd had you do just a part of the mock exam, so I wasn't going to add on top of that. But now that those things should have been cleared, if you were doing it at the pace I suggested, I am going to start throwing a couple more mini quizzes at you. So before we go any further, you need to make sure that you mark down the thing that you need to study. So your mini quiz will be a matching quiz. This will be tomorrow morning because it's a B week, if you forgot that. And it's a matching quiz over 131. 131 was those 3 pages you picked up yesterday or Tuesday, but it's only over the front and back of one of those pages. So probably important that you mark down which page it is, unless you're going to go through and learn all 3 pages. So front and back of the page that has f of x is decreasing in the top left. So again, there's not like questions for you to do on that assignment, but you need to know those things. So that's where it'll be matching. When you see this, this is what your approach should be. When you see that, this is what your approach should be. Just kind of helping you put some thought into how you start each question and what calculus you should do based on the wording and stuff like that. So if you have any doubt about you knowing what page that is, please double check and have me visually confirm it with you today. Otherwise, if you don't do that, then you're gonna maybe mess yourself up. Now again, there'll only be a couple points in gradebook, but they will be major points. So we've done, I don't know, like 4 or 5 of those already. So we'll start adding a couple more major points here and there. Of course, your Delta Math will also go in as major points. So, and that will be the last big test grade that we have in there. Okay, also, before we talk about what we're going to practice today, I have a short little Google slideshow that gives you some perspective about the AP exam, just like what the kind of scores are worldwide versus Fayetteville High School. I don't know. I just give you some perspective, so I'd like to just skim through that real quick. And honestly, I will probably bring this up each class before our AP exam. We actually only have 7 more days, including today anyway, 7 more class days. And that's assuming that you're not sick for any of them. It's assuming that you don't have any AP exams where you might miss a B day the week before. So it goes quickly. But each time we look at this, I'm going to spend less and less time on it. I think it's important for y'all to get these kind of perspectives, but I'm not going to give a 10-minute presentation on it every single class. But so they don't always share the cutoff scores, but here are the cutoff scores for the 3 most recent years. How many points out of 108 you had to get a 3, 4, or 5. So there is a little bit of variation, anywhere from 34 points to 45 points for a 3. I know some of you, there are a few schools that only take 4s and 5s, but you probably know if that's you or not. And I have mentioned this in the past, but the cutoff score, yeah, it should be over there. The cutoff scores vary because it's a scaling test, just like the ACT. They'll grade all the raw scores based on the raw scores. If the raw score average is low, they consider it a hard test, which means you need less points to pass. If the raw score average is high, they consider it to be an easier test, and they're going to expect you to have more points. So you can see in 2022, they must have thought the test was easier because they expected students to have 45 points to get a 3, as opposed to 34 in 2008. That's the second most recent time they've shared the cutoff scores. To me, that is very, very important because there's a chance you sit down at your AP exam and it feels like it's pretty easy. Or there's a good chance you could sit down and you could think this is harder than the mock exam, or this seems to be a harder version this year. Either case, you need to put in your best effort. If it's an easier exam and you start coasting, the cut score could be higher and you could be messing yourself up by coasting. Likewise, if it's hard or seems harder than normal, just saying I give up, this is harder than I expected, it's probably harder than everybody expected, and the cutoff score could be lower. So either way, you should be putting in your best effort. These are the cutoff or the pass rates for Fayetteville High School on the left, as far back as the data that I could see. So we've had years where the pass rate was as low as 37%, and recently pass scores as high as 62.5. This is my 5th year of teaching, so those are my numbers on the right, just for comparison. I just know a little bit more about those, the breakdowns of 1, 2, 3s, 4s, and 5s, if that matters to you. 2020 was the year that COVID happened. It's also my first year teaching calculus. Year 2, you can see there was a pretty big drop. That was the year that we offered virtual hybrid schedule. You remember that? Like you may only came to school 1 day a week or something, or no days a week. So some people just didn't really try much that year. But last year's group did great. You can see that they've been kind of bouncing back. So just need you guys to trust me that I am trying to get you the best practice that I can. But for worldwide AP scores, here's the data that I have. I think really the only thing to get out of this is that it's pretty steady. There's not one year where there's 1,000,000 5s or 1,000,000 1s. Again, since it scales, there's pretty much the same percentages of 1s, 2s, 3s, 4s, and 5s each year. Okay, this has been a couple years since I've done this, an AP workshop, but the guy leading it was he's probably like the third biggest calculus teacher in America. So he does a lot of stuff with College Board, does the grading of the AP exams, all that kind of stuff. And he had a few quotes that I felt like were worth sharing with you guys. Now again, I did this workshop in 2021, and he was talking about the year before that, so take that with a grain of salt. But he had said that last year's scores, that half of the students that scored a 2 on their AP exam would have been a 3 if they only had 3 more points. So you would hate to get a 2 when all you needed was 3 more multiple choice questions or 3 more points from any one of your 6 FRQs. Also, to go from a 2 to a 4 was only 11 points, so not as significant as you may think. When you're doing calculator FRQs, make sure you write down what you're typing in the calculator. If you know what to do, you go straight to the calculator, you type it in the calculator, you hit enter, you get the answer, and you write down the answer. That's considered a bald answer. That's not worth any points, even if it's correct. Anything you're typing in the calculator should be considered work that you need to show. No justification explanation should be more than 1 sentence. So, a lot of times we would say the function's increasing because the derivative is positive. It's concave down because the second derivative is negative. If you are getting very wordy and trying to justify your answer, you're probably missing the mark. More than 1 sentence, you're probably on the wrong track. And you're welcome to stop when you have a numerical answer. So we've talked about you don't have to simplify any arithmetic on FRQs. Now, that's not the same as like f of 5. F of 5 is not arithmetic. That means go to function f, plug in 5 for x, and solve for y. Like, you have to still do that. You still have to do the calculus. But if you have an answer, a half plus a third plus 7 minus 11, that's arithmetic. You can circle it and move on. You don't get any extra points for doing the arithmetic. Okay, the next 2 is actually going to lead into the next thing I need to share with you. So he claims that, again, this is not me, and this has been a couple years, so everything with a grain of salt here, but he claimed one FRQ is always one of a geometric graph, and one FRQ is always a rate in, rate out. And didn't we practice a rate in, rate out recently? Didn't we do the banana problem in here? Yeah, okay, that's a rate in. You've got a function that tells you how fast it's adding. You've got a function telling you how fast it's removing. And of course, if those are a guarantee to be on your AP exam, or very likely to be on your AP exam, I think it would be a big mistake to not feel fully prepared for those. Always round to 3 decimal places, and if a function says it's differentiable, just go ahead and write down that means it's continuous also. Any function that's differentiable is continuous by default, but I don't know why they make a big deal out of this, but there's some points you can't get in FRQs if you don't say that. So as soon as it says the function is differentiable, you might add that means it's continuous. If you didn't need it, you didn't need it. It took you 5 seconds to write it down, but if you needed it, it was there. Okay, I'm not going to do the whole thing with you guys, but last year I let them brainstorm some ideas on why you would want to pass the AP exam, so this is what they came up with. Their words, not mine. Although third period yesterday seemed to relate to the family not disappointed in me. So the big one, in my opinion, though, is the very first one, time and money. Of course, you guys passed the AP exam. You're going to get Cal 1 credit. That's one less class that you have to take in college to get to your degree. I know sometimes I've overheard students say, well, I've decided I'm going to do X, Y, or Z major, and that major doesn't need calculus. The mistake that you're making there is that college, just like high school, you have to have a handful of electives. So no matter what your degree is, they're going to expect you to take a couple history classes, a couple science classes, a couple math classes, a couple English classes, and then a bunch in whatever you're majoring in, but then also a handful of electives. So sure, maybe your major, maybe you decide that you're not going to go into something where you need calculus, but at the very least that would count as an elective credit. And that's one less class you have to go to, one less class you have to do homework for, one less class you have to pay the tuition hours for, just thousands of dollars. One more class that you could take of something else to potentially finish a little bit quicker. And part of the finishing quicker is college is a lot different than high school in that, you know, you guys are told take this many classes, 4 years, and then assuming you don't fail a bunch of them, you get to graduate. College is not the same thing. They don't care if you take 2 classes a semester or there is a limit, but about 6. So at some point you might want to look at this. This is from many years ago, but a local newspaper, Arkansas Democrat Gazette, started tracking some students and then that went to Arkansas schools. And they tracked how many of them had a 4-year bachelor degree after 6 years. After 6 years, most schools are in the 20 to 30%. So it's not like you get to college and you're just automatically going to finish in 4 years. You're only going to finish in 4 years if you really hustle. So having more classes under your belt gives you a lot more breathing room. Me specifically, I did have to withdraw from one class and retake it in college. It's a long story, but I passed everything else and I did 4 or 5 summer classes. And I still had to take 21 hours my last semester of college to finish when I did. And 21 hours is more than they'll even let you do. You have to get a waiver to do that. So I was pretty much on top of it, and it was still tough for me to finish in 4 years. But I had to do it because I wanted to do my grad program, and if I missed that window, then I had to wait a whole year. So that's why I pushed myself that way.
What degree did you get?
Huh?
What degree did you get?
Bachelor's is in math and master's is in education. Okay, and then I will have you guys do the same Google form, just kind of how you feel about the test before and after, so I can share with next year's group. So this data is from last year's group. I asked them, I gave this to them about this time last year, and I just asked them, how did you think you would do on the AP exam, AP Calculus exam before the school year even started? Before you knew any calculus, before you knew it was going to be your second period class, you know, just based on what you'd heard and how you felt. And this is what they had said. Okay, same graphic on the top, but now on the bottom, this is how they felt right before the AP exam. So, once they had gone through the class, you can see just in general, they felt a little bit better about it. Okay, now the right before the AP exam is at the top, and the right after is on the bottom. Now, there is one catch to this. This data doesn't show senior data, just because seniors were already gone when I did that. That's why the numbers are a little bit low, but should be pretty standard across them. So, I would say that they probably felt a little bit better after the AP exam than before the AP exam. That's what I'd probably get out of that. Okay, and then how they felt right after the AP exam versus what the scores actually were for last year's group. Now again, I don't have a specific message here. I'm just trying to give you some perspective. There are people who thought they were going to get a 2 or 3 and ended up with a 1. There was a couple people who thought they would get a 5, and it was more than double the number of people that got a 5. So, I don't know. But I figured just the big picture here certainly doesn't hurt you. Okay, so I'm going to go over that several more times, but much quicker each time, because I think there's a lot of valuable stuff about putting in your best effort, how close you can almost get to passing if you don't put in your best effort, etc., etc. But anything you guys would like to ask about that? Any of those slides?
Do you usually have seniors come back after May 3rd but before the AP exam? To sit
Yeah,
down?
yeah. If you're a senior you guys get out before the AP exam, you're welcome. You're certainly encouraged to come to class. Like, obviously I can't make you come to class, your grade's not tied to it, but it could end up being the difference between passing and failing, and coming a couple of days versus having to go a whole semester plus more homework plus studying for a test. You know, I don't know, but maybe you're more confident and maybe you don't think that you need to. You're also welcome as a senior. I mean, my website's still going to be up. It's still going to have the class recordings up. I'm still going to post our review material. So, I mean, if you can't come, but you'd like to still participate, that would still be an option. So, I'm good with whatever. But the school is happy to let you guys come those days. So, and I'm certainly encouraging you to do that too. And again, the bright side is you're not tied to the grades or homework. So, anything else that everybody else was having to do, if you didn't feel like doing it, you could just say, no, I'm not doing that, and I can't give you a 0. So, okay, all right, and then finally, sorry, I know I had a lot here, but okay, so something I've been working on, and it's still pretty far from finished, but I did add this to the website yesterday. So this class website, at the very top, I have a link to something called FRQ database. So if you click that, it's going to look like this. And so what I've done is compiled or started to compile a lot of information that is out on the internet in several different places. But just like that guy who did the training said that rate in, rate out is always an FRQ, and the geometric graph analysis is always an FRQ. I'm just trying to put this information in one place. So the 6 most common type of FRQs are the rate in, rate out, linear motion, particle motion. That's like, you know, particles moving, here's its position, find its velocity, find its acceleration. Graph analysis, which is where you usually get like a first derivative graph and have to answer stuff. Area and volume, so that's the stuff we've done recently. Area between 2 curves, volumes, this method, Washer method. Tables and Riemann sums, differential equations and slope fields. There are some others that don't fit into any of these categories. Like there's just some that, I mean, but those are the 6 main ones. So those are the ones that get asked almost every single year. And I have a type 8 of FRQs that I just haven't had time to categorize, which is pretty much the last couple years. But as you get closer to the AP exam, let's say rate in, rate out, you say, I'm pretty sure it's going to be on the AP exam, and I'm not 100% sure I know that I'm ready for that. You can either use these tabs at the bottom, or you can use this link. And then what I've done is I've collected all of the rate in, rate out FRQs that I know about. So 2022, number 2, 2004, number 1, 2005, number 2, 2006, number 2, 2007, number 2, 2008, number 3. So I'm trying to show you how often this FRQ type gets asked to convince you it's worth your time. And you can see I don't have links for everything, but it tells you if a calculator was allowed. It has the average score if that information is available. And then for the stuff that I've had time to link, which again, I just haven't had time to do all of this just because there's so many, because there's all these different types. But if you know you need to practice this and 2007, you want to try it, you can click this and it will download the practice for you, or you could click this to do the scoring, or you could click this to find a video to help you with it. So I'm just trying to make that as easy and convenient for you as possible. And if you're not worried about that type, but you don't know what I mean by graph analysis, you could go to that tab. I've got a bunch of them linked, a bunch of them you could score, a bunch of them you could get help with from internet videos. So I don't know that that matters to you right now, but I just feel like practicing the most common FRQ types and being as ready for those as possible increases your chance to pass the AP exam by a lot, and it should make you feel a lot less stressed by feeling like you probably know and are comfortable with a few types. So again, I just want you to be aware of that because I think that is going to be helpful to some of you. That's the whole reason I'm doing all of that work. But it is now linked at the top of our classroom page. Okay, on to today's stuff. I think that's all the administration stuff I have to get out. So first up, I would like you to finish 130. I think a lot of you did finish that last class. That was the circuit on product rule, quotient rule, and chain rules. Again, I didn't ask you to finish it for homework because I told you about the delta math and asked you to do that for homework. So if you don't have it finished yet, that's fine, but that's what I'd like you to do first because I will ask you to turn that in as part of your homework. So if you need help with it, then the next 20-30 minutes is where I should be helping you with it. After that, I would suggest that you read through the 131. When you see this is what you do. So I asked you to do that last class too. Some of you had time to get to it, some of you did not. I'm just giving you more time to do that because I didn't ask you to do it for homework if you didn't get to it. And then finally, the handout you guys picked up on your way in is another circuit, but it's a pretty small one. 12 questions total, and it's about tangent lines and using tangent lines to approximate. So I'm actually working on something else to share with you guys to help you, and I didn't really realize this, but on your mock exam, this skill, tangent lines and tangent line approximations, showed up as 2 multiple choice questions, and it showed up in 2 parts of 2 different FRQs. So that was worth, like, just that one skill was worth about 4.5 points on your mock exam. So, you know, again, this year, I don't know. I know it'll be on your exam. It's probably not going to be 4.5 points, but even if it's a couple of points, just making sure that you have those under your belt and worry about something else later is what I'm asking you to check off the list today. Okay, and if you're super far ahead, then I'll ask that you use the rest of your class time to look through your mock exam, multiple choice questions, and just try to learn from some of your mistakes. But that's only for those of you that work super quick. Will you get to that? So, all right, let me get these homework grades put in, and then I'll come around and help you with the 130 circuit that we started last class and or the 132 circuit that you picked up this morning.
But that's like the grade.
Yes. No, we'll run 1:30. We didn't finish it yet.
Is there any difference, like on what classes you skip, like getting a 3, 4, or 5?
I'm sorry. Say it again.
Is there a difference on what classes you get out of if you get a 3, 4, or 5 on the exam?
Only in the sense that each year is a different test and there's a different cutoff score.
No.
So, I mean, it just depends.
Like, is Cal 1 the only thing that you can?
Oh, well, are you a
Was-
senior?
No.
Okay, are you doing BC next year?
Mm-hmm.
Okay, so if you pass the AB exam, you can get Cal 1 credit. And then if you pass the BC exam, you get Cal 2 credit.
Okay.
It's the rest of Cal 2. Okay, I've got all the homeworks in, so as you guys find something math related that you need help on, just call me over as I come around, please. Okay, so this one's just a weird way to ask it. I'm not a fan of it either. But if the function's the square root of x and you're trying to approximate the square root of 8, they want you to plug in an 8 for x, not the square root of 8. All of these should be ones you can do without a calculator. You're not going to do square root of 8 arithmetic without a calculator. Yep. I saw you on Facebook again. You were teaching some little kids something.
Yeah, yesterday we went to McNair, and we did like invasive species, like slideshows and stuff.
Is that part of your class that you have to do that?
It's like, it's one of my friends' like special, it's like a year-long project, and they do it every year, and like, depending on how involved you are in the class, like, you can do it, and it's just, it's really fun, and like, they actually like learned a lot, you know?
Yeah. That's cool. That's a big commitment to offer to do that. So.
Yeah. But it was fun.
Were the kids well behaved or?
Some of them, but like, it was just funny, like, some of the teachers would be yelling at them, like, because we like removed some of we removed like a part of their stuff, because they have a lot of invasive species over there, and we like showed them, and we were like, okay, this side compared to this side. And one of the teachers were like, you guys are being so childish. It is so childish to look at strawberries and throw sticks. And they were like, can our volunteers attest to this? And no one said anything. And I was like, yeah guys, there's no childish behavior allowed in high school. And like, it was so weird. It was uncomfortable, but like, for the most part, it went really well.
Yeah.
Y'all should have pretended like the kids acting up were invasive species and like
Yeah.
just to drag them away.
That would have been really funny. But yeah, it was fun. It was really cool.
I got you. Yeah. Yes. I don't think that's it. Is it, you think that's it? This is the one percent.
Okay, I'm gonna work on something else for a couple minutes because it doesn't seem like anybody has any questions yet, but I can do this stuff later, so if you guys find a question before I come around and bug you for some, please don't hesitate to call me over or bring it up here.
I don't know if I have these right, but I
Okay.
did derivative of f.
Mm-hmm.
Yeah. And then put in 1, got 3, so that's really slow.
Mm-hmm.
And this is just f. So then that got me 3 halves.
Okay.
And then 1.1 got. That's not really it.
Everything sounds fine. This is negative point. Is that negative?
No. It's 1.1 minus 1, so it's just 0.1.
So your slope should be negative 3, not positive 3.
Oh.
Something's off on.
Oh, yeah, I did what? Yeah.
Yeah, so that's negative. So that's negative.
Okay.
And that's negative, and then that's going to change that a bit.
Okay.
I should end up with 6/5. get the slope. It should be. I'll have to erase this later. Okay, so here's point slope. This is what you're aiming for. Plug in that x value into the derivative gives you slope, and I think that's supposed to be -3. They tell you the x value. To find the y value, you have to plug the x value into the function, and that'll give you this. Okay, and then this whole thing would be your tangent line, but for the approximation piece, you'll have to plug in 1.1 here and then solve for y.
I have a question. So, for this is my 4, and
That's fine, except you lost the square down there on the denominator.
okay.
Also, the way you're writing it, it looks like you're squaring x and not squaring sine x. So you should probably either do parentheses
Okay,
or
yeah.
move the square over how we do it in normal trig functions.
Okay.
But I think what you've been doing is fine, but it doesn't look like any of the answers should.
Yeah.
So they simplified by, you can always split apart the numerator of a fraction, so they put this over this, minus that over that,
Mhm.
and then when you try to simplify each side, then it'll look like one of their choices.
Okay, perfect. Thank you.
Okay. A product rule. Okay, sure. You did you did the first derivative by doing product rule, but these twos means they want the second derivative. So the scary part is now you're gonna have to do product rule here and product rule here for 3 times. We talked about this one, I think you were gone that day. So you can try that, and I tried it, and I tried to do it very carefully twice, and I missed it both times. Then I realized that up here, this simplifies if we do that before we do any calculus. Since tangent is sine over cosine, so all of that is really just sine. And taking the second derivative is way easier than doing the product rule 3 times, and then trying to simplify it all, so. I mean, go for it if you want to. Would recommend. This is doing okay?
Yeah. Move. We heard you tell AJ about 7, so I think that's helpful.
Oh.
You're stuck on this one too.
The chamber one?
Yeah. You said it cosine to cosine x times sine x over cosine x. So it simplifies.
Yeah, so it's not wrong to do that, it's just harder.
It was, yeah, well, I messed it up.
Now I'm like, well,
I don't know, I would just restart first, but,
Yeah.
because as soon as you figure out that sine, the derivative of sine is cosine, and the derivative of that is negative sine, and then you're done. That's why you should always try to do fraction word, algebra word, anything you can do before the calculus usually makes the question easier. In that case, forget it. One is, there should be a minus sign.
Yeah, sorry, I'm not learning
your word. Also, you got these, you gotta do the derivative of the numerator first.
I just forgot
No,
on
they
there.
are left alone, and then minus, then do it the other way. So we need to fix that. You might wanna look up in your notes and break down the pattern at the top. And then 2, it's still gonna look like that even after you fix it. So what you're gonna have to do to make it look like one of theirs is you're gonna have to split apart your fraction. So you're gonna have something minus something. So if you put this over this and then minus this over this, simplify each fraction, it will look like one of theirs. Okay, so here, this is just a weird one, I don't like how they do this, but they do it a couple times here. So now this is square root of x, and this is square root of 8. So they really want you to approximate x equals 8. It sounds like they want you to plug in the square root of 8, but they really just want you to plug in 8. Yeah, and then up here, here's the other one. Natural log of x is the function, so natural log of 1.5. You're wanting to plug in 1.5 for x. All of these you do the arithmetic about calculating, so you get something weird like square root of 8. Yeah.
This is definitely nice because this is something I was completely forgot about, so.
Well, you can forget about it, you can just rest
Yeah,
and then I can do what's
not yet.
On this problem, it says that, so I found the with all the
Okay. On the that doesn't change any of your work for that question. It's gonna come into play later. You're gonna reference that question later, and you're gonna need to know its concavity when you get to it. Yep, but you don't have to know concavity. You can do
Well, I thought this was this is lower than that. Or his estimation.
correct, yes, and that's what they're gonna ask you about.
Thank you.
This one's just kind of strange, but you see how this, the function square root of x, and then this says square root of 8? So they really want you to plug in 8 for x,
And then it's something.
not the square root of 8. It's a really weird way to ask it. But then they do the same thing up here too. I don't know if you caught that, but natural log of 1.5, natural log of x. They just want you to plug in 1.5 for x. All of the arithmetic is stuff you should be able to do without a calculator. So if something seems like a weird decimal or something, then you might be plugging in the wrong decimal. Sorry. Sorry, I'm really not trying to get you off there. Okay, y'all have something I can help with math? point. You need to put the points in, define the derivative. But your derivative, yeah. But this doesn't have y values.
Yeah, but when I take the derivative,
Correct. Yes. No. That's
how will I
what
know what one prime is though?
because when you have 3x squared plus 2y. If you're taking the derivative of this with respect to x, this would be 6x. This would be 2y prime.
Because the y goes to
Yeah. And so there you go. There's your derivative.
and then you would plug in the point to find what this
Yes. You plug in 1, 1. Everywhere there's an x, I think it's 1, 1. Everywhere there's an x, you plug in a 1. Everywhere there's a regular y, you plug in 1 for y prime. They give you what you need. They give you a point and a slope. You're ready for your tangent line already. They made it easier on you. Just different notation.
But the y is, it doesn't go away.
Y.
Yeah, that's true, because you have the y value.
Oh, okay, I see what you're
Yeah,
saying.
just plug in the x value and all the x's, the y values and all the y's, and
Okay.
then you can solve for the slope y.
Okay.
And then this plus 3y.
Plus 3 is the y. Okay. Now I'm just
I'm starting on this, so I guess it's give back.
Okay. Plugged in 1, plug in 1 here. Let's use the calculator just to do it faster. That's 4 plus 1.
Oh, so I just got that.
This should be, yeah, this should be 1.5. This should be 3 over 2 here.
Oh.
Let's see, yeah, right here, because negative 4 plus 5 would be 1, plus a half would be
Oh, that's
1 and
plus-
a half.
I subtracted that.
Yeah, so, okay, so now that looks good. So here's your tangent line. Now they want you to use it to approximate 1.1. So now plug that in for x, and then subtract those would be 0.1. Times negative 3 would be negative 0.3.
Yeah.
Add over 1.5, and then change it back to a fraction.
Alright. Thank
And you should end up with 6/5 on that one. Obviously, if you don't remember tangent lines and you're stuck on the first one, you guys should ask sooner rather than later. The longer you wait to ask, the more you're going to have to do for homework at some point. Okay, and you guys still have almost 40 minutes left, so still a ton of time.
For number 5, I don't understand what that means.
Well, they want you to, okay, so right here, when you plug in 1.5 for x to approximate, you're not going to know what 1.5 minus pi over 2 is without a calculator. So they're saying just round pi over 2 to 1.57. So then you can do it in your head.
Thank you.
So it should be negative.
Can you explain this one?
Yeah.
The derivative of this is not.
Okay, so since the second derivative's negative,
Yes. Concave down.
okay, so does that make your approximation an overestimate or an underestimate?
Yeah.
Under?
Well, if it's concave, this one's down. If it was concave up, it's gonna look like this. So your tangent line's gonna look something like that.
Oh, so it would be over.
Sine.
Right, so your estimate versus the real is an under if it's concave up. Whereas if it's a concave down, your estimate is above the actual.
Okay.
So,
Thank you.
What was the other one?
Yeah, it's just the same before and that's just the denominator that just integrated. So it would interesting, okay, yeah, okay. Yeah, that makes sense. Okay, slay. I guess I probably need to find some reason for that quiz. Google login. Also, instead of doing the marking, it's double. I don't know, I don't want. I said like. Question answers. And the book actually.
What was that? Like, wasn't that the derivative of x, or the cube root of x plus 1?
I don't, are you saying this is your derivative?
That's not the derivative. I was just about to do the derivative. That's the derivative.
Okay, you shouldn't say that this is h prime then.
Okay.
You should say that's just h. So bring the power down, lower the power by 1, no chain rule. Okay, so that looks good.
Okay.
And then plug in, why is this a 10 though?
Wouldn't it be 11, so 11 minus 1, 10? And then,
Well, you're trying to figure out the slope first. You need to write the tangent line equation first before you worry about approximating.
that goes into n, right?
Mhm.
I was just like thinking about putting it right there. But
Okay, so, but yeah, but if you plug in, you're plugging in 9, so 9 minus 1,
oh, I didn't even plug.
That's what I'm saying. I don't see how that would have been
Yeah, I didn't-
intended anyway. So
Frankie showed me her like pictures of this. Did we explain like how I would figure out if it's under or over an estimate?
sure, it's all just based on the concavity.
Okay.
So if it's this is concave down, but if it was concave up, your tangent line doesn't look the best here. But
Yeah, sorry.
no, it's okay. But if it was right here,
Mhm.
here's where you're estimating the point to be, but here's where it actually is.
Yeah.
So when it's concave up, your approximation's below where it is. When it's concave down, like this question, here's your tangent line. So this might be your approximation, and down here would be the real one. So this
Okay.
isn't over if it's concave down, but this isn't under if it's concave up.
And then does it matter which? Because it says like go to this number.
Mm-hmm.
So is it an under? Like what if I'm confused on the like?
Well, is this one concave up or concave down?
Concave down.
Oh wait, okay, so yeah, they're giving you some hints here. So
Mhm.
back to question 6. Question 6, was it concave up or concave down?
Concave up.
Okay, so if it's concave up, is that an under or an over approximation?
Under.
Okay, so if it's under,
Okay.
go to here.
Okay, that makes sense. Thank you.
Did you try? It should be times 2 because chain of it. But can you see yeah.
Is this the right number 4?
That is not what I have for 4.
So, let's go back to 3.
3 looks fine. Let's see. I have the slope as 2/3, not.
I think I lost the 2.
Oh, yeah. Yep, that would do that.
Alright, thank you.
Okay, does anybody have a math question I can come help with? We're down to about 20 minutes, so if there's something you want help with, we're running out of opportunities today.
Maybe this is a 2x, you multiply everything.
Here's Dr.
You need to give that to the office. I only mark what time you show up, and if you're here or not. They're the only ones that can change it to doctors.
Alright.
So, to write the equation of the tangent line, you need to start off in point slope. So you're going to plug a point in here and here. So I think they just gave you the x value in that question. Isn't x1 in that problem? Okay, so to get the y value, you need to plug 1 into the function to get the y value. If you want a point, you plug into the function. And if you do that, I think it's 3/2. To find the slope, you need to plug the x value into the derivative. So you need to take the derivative, plug in 1 into that, and I think that gives you -3. I think I'm going off memory here. So this is your tangent line, and then sometimes that's all you need, and then sometimes they want you to use this to approximate something. So in this question, they want you to approximate when x is 1.1, so plug that in for x, and then we have something we can solve for y, and then I think this comes out to 6 bits. That's the answer they're looking for. So practicing setting up the tangent line, and then plugging in an x value to approximate. What is that?
It's just water called. I said water, that way I accidentally.
Not unless it's a general question.
No.
Okay.
It's just water.
Is this?
I sent it to you, so you heard it before. Unless you didn't listen to it, which you did, shame on you.
The big R little R minus that number or plus that number? Also, remember, like when you're putting it into the like pi, and then you have
Pi big R squared minus little r
Well,
squared.
actually, I think that if you're rotating around a big R, you're more big or like if it's not rotated around the wire, it's rotated around like.
If it's rotated around a vertical line, like the y-axis, you would integrate dx, and then use x values.
Yes.
If you're rotating around a horizontal line like the x-axis, you would integrate, or I'm sorry, that's the first one, dy, rotate the y values. Horizontal lines like the x-axis, you would integrate dx, and use x values for the one.
How would you like, if you're rotating around that, like if it's 3,
And every axis is
right here, do I like do 3 plus that or 3 minus?
Whichever one makes sense for the question. It could be either way.
If it's shifting to the.
What I would do is plug in values. Like if you can see what the big R is at a point, like whether it's 0 or 3 or something, come up with what you think the big R formula would be, plug in that information and see if it gives you the value that you expect it to be. Well, I don't know, just do 3 plus whatever, and then plug something in, and that would tell you what the radius is at that time. And if your picture looks like that, then that might be right. If your picture doesn't look like that, then it can't be right. And maybe it's 3 minus. No, I can't do more than that. You might look back at your circuit and you get something like that.
I only have like 2 on that. These questions are harder.
Not harder than they're going to be in the IQ test. Not harder than they were on the mock Don't they give you videos too?
Where? I'm glad we watch a video.
Oh, maybe that's not until the corrections.
I'm skipping it.
I don't know, try to refresh.
No.
I'm doing
You
it.
have to use
If you
H2
restart your
square root
computer.
H.
Other people are getting in, so I'm not sure.
It's already functioning.
You should just use your school login.
What? Approximate square root 8 is in square root x.
Yeah, but
at
her
x equals
login
2.
with Google button was grayed out.
That's weird.
Yeah, mine was too, I think.
TJ, where's the difference?
It's a problem with the, like, physical price.
Well, that shouldn't be too bad, because you don't actually have to do work on your phone, you just have to see the questions and type it in, so. That's unfortunate. Oh.
It worked in class, which I don't think.
Clause online.
This is the area where you just like.
I worked through pretty much every question he had before I started teaching calculus, the summer before, just as for you.
Would it be like the next one?
Lots of practice questions, answers to check the words, so.
I used that for a couple of other things this year.
What, clause online?
Yeah.
Oh, for this class?
Monday
Oh,
I was
okay, I didn't know he had other stuff.
Tuesday I was just looking.
Yeah.
And then I came to school.
Yeah, it's one of the better places if you just want to practice questions.
Monday.
That's what I was doing.
So it was like 17.
Yes.
Yeah, that's what. Okay.
Section's so bad.
You have to do a voiceover or something.
Yeah, we're gonna narrate. I mean, like, we have dialogue, so we're just not getting it yourself. That was a big one. It's very cinematic.
Oh, for those of you that are seniors, it doesn't have anything to do with this class, but I did ask about exemptions for the classes that you're trying to exempt from, and I think they're going to send out something on Monday next week. I think they'll let you start applying for exemptions then. So, again, you don't have to worry about that for this class because we don't do a final second semester, but for some of your other classes, you might want to be looking for that.
just skip writing down that entire step, which is why you're supposed to not showing your.
Oh, it's like, when you think of concave up and like concave down, if you're putting a tangent up there, it's not, you drew it out, like, if this is like concave up and this is concave down, if you're doing a tangent line, like connecting to it, if it's concave up, it's gonna be an underestimate, and if it's concave down, it's gonna be an overestimate of what the actual slope value is gonna be. That makes sense. Okay. It's just like, it's an under. Is it underestimate or over? No, it's over. I meant. So then it's just like the end of the circle because it connects back to the first question. Wait, no. It goes 12.
I changed your answer.
Yeah, it's like the quotient rule to find the slope. Yeah, and then but the slope is 0 when you find that. So then it like, yeah.
I'm gonna get it done.
Yeah.
And so if I know the color, just, it's only 8 constants. Then I won't have to do
So it's like, wait, let me see if it's better than this. So it has an interval of pi, and then I just put in between the two, and I don't say. Wait, no, it would be. Wait, I think it's actually the X value. So would you from like?
We're so fast.
I thought you guys were wild when you're rotating across the x-axis. And when you're rotating across the y, use the x values. Yeah, but like it's technically like the y. See which one, just see if there's. Yeah, for number 16.
Yeah.
Oh, I saw that, that's funny.
How do I grab something?
Where they intersect is where it's gonna create area, and where it creates area is gonna create the volume.
Chloe, do you know how to set your attending college and audience?
I do not.
Your graduation ceremony?
Yeah, but if you show me, I can see about it, because I know I did it, I just don't remember.
So I did my graduation survey and it was like, you have to set your attending college for us to send them the file transcript.
So I think they give you.
Oh, God, I don't know what it's.
Where the points of intersection are, and then use those.
Did you not do well this semester?
I mean, I did, but I just.
Sometimes they show it to you in graph, sometimes we have to like do equations with people because they're involved to figure out what's happening.
I'm going to be.
So maybe.
All right, guys, for now, we're down to about 2 minutes. So, again, just to be clear, make sure you know what the mini quiz is tomorrow. If you're not 100% sure, bring it up here. Let me verbally confirm that you're looking at the right thing for the mini quiz. Because I'm asking you to study for that mini quiz, the front and back of one page, you don't have to have today's circuit number 132 finished. You don't have to do that for homework at this point, because I'm asking you to do something different for homework. But if you're still not finished with the number 130, then I guess that needs to be homework for you to catch up to everybody else, because this is the second day I've letting you work on that one. So turn in 130 and then make sure you study for the mini quiz. It's a B week, so I will see you again tomorrow morning.